Good afternoon, everyone. Welcome to the Cloud and Web App Security, a webinar by LMG Security. My name is Sarah Edwards, and I'm your moderator for today. Our presenter for the webinar today is Matt Duran. Matt Duran is the Director of Training and Research at LMG Security and a Black Hat USA instructor. He holds his computer science degree from the University of Montana, and his malware research has been featured on the NBC Nightly News. Matt is a co-author of the new book, Ransomware and Cyber Extortion. Matt, I'm passing you control of the webinar.
Thank you so much, Sarah, and thank you everyone for joining this afternoon. We're going to be covering the topic of cloud and web app security, which is a topic which has really become top of mind, especially over the last couple of years. With COVID-19 and the move to work from home, a lot of us moved to cloud services as kind of a primary driver inside of our business. We do cloud file storage, cloud email, cloud applications for all kinds of different purposes, both inside and outside of our organizations. And the level of security we've come to associate with cloud applications specifically has been kind of in question lately, especially with some of the more recent hacks in the media. We'll go ahead and cover a few of those as we work through the presentation today. Again, if you have any questions whatsoever, please feel free to submit them to the Q&A tab so we can answer them at the conclusion of the webinar, and enjoy the content. So for those of you who are new to the LMG webinar series, again, my name is Matt Duran. I'm the Director of Training and Research for LMG Security. I'm a Black Hat USA instructor. I've been a featured speaker at the RSA conference in San Francisco. And recently we released a brand new book authored by myself, Sherry Davidoff, our CEO, and Karen Springer, our COO, called Ransomware and Cyber Extortion Response and Prevention. It's available on Amazon now. So if you've ever wondered what someone like me does behind the scenes, when it comes down to responding to large-scale cybersecurity incidents, negotiating million-dollar ransoms, or any of the other kind of fun things that we get to do, highly recommend that you check it out. It's not just for nerds, I promise you that. All right, so the roadmap today is going to cover a number of topics. The first thing we're going to talk about is Microsoft and a recent hack that they suffered. Yes, even organizations like Microsoft can occasionally fall victim to a cybersecurity incident. We're going to talk about web app misconfigurations and flaws, some of the simple mistakes that are made in web application design that can lead to unintended consequences, whether it be through unintended actions, unauthorized access, or the leaking of potentially sensitive data. We're going to cover MoveIt and a quick update on how that entire situation is going. If you've watched our webinars over the last few months, you've known we've covered this quite a bit, but it's an evolving situation and something we see as being relevant for quite a bit of time to come here in the cybersecurity industry. We'll cover accidental data leaks, and then we'll wrap up by covering Amazon Web Service security problems. We'll give you a demonstration on how we can break into something like a misconfigured Amazon S3 bucket and hijack the data that's being stored in there. All right, so as promised, let's start off with Microsoft. So Microsoft unfortunately revealed pretty recently that they had been hacked. There had been a break-in of their, a compromise of their credential system, specifically when it comes down to what's referred to as a signing key. We'll cover what that is here in just a second. But it meant that a group called Storm 0558 was able to compromise upwards of 25 different large organizations, mostly government, and potentially compromise the contents of their cloud-based email and file storage. Now, we'll talk about exactly how they did this, but before we really get into how this attack happened, there are a few things that we need to cover just to make sure that everyone's on the same page. The complexity of a cloud cloud application attack can get kind of high, and we don't want to leave anyone behind who is not familiar with some of these terms. So let's go ahead and cover a few things first, then I promise we'll get right back into the storyline itself. So cloud data in general is protected in three ways on the internet. The first one is going to be authentication. We want to verify that the people who are attempting to access this data are actually the people they claim they are saying they are. Oftentimes we do that through simple authentication, usernames, passwords, and multi-factor authentication keys, something like a thumbprint, biometric authorization, a facial scan, a retina scan. You get the idea, right? We're trying to verify you are who you say you are. The next way we do that is through authorization. Oftentimes this comes down to identity and access management. We'll talk about that near the end of the webinar when we talk about Amazon. This basically just guarantees that the person who is accessing the data that they are accessing has the rights to access that data. We don't want to leave data open for absolutely anyone to access, especially if it's sensitive. And so we want to control that kind of access inside of our systems. The last way we normally protect data in the cloud is through the use of encryption. We're going to scramble data so that only people who are authorized to view it and have a key so that they can unlock that data are going to be able to actually access that content. So we'll cover really quickly, what is encryption? Encryption is simply put just modifying data so it can only be understood by an authorized party. And here's a quick kind of toy example of what that looks like. We have two people sending a message back and forth to each other. We have the man on the left, we have the woman on the right. The man on the left would like to send a secret message to the woman on the right. And so what he's going to do is create his message. He's going to say this is a secret, and then he's going to encrypt that message. So you can see in the middle, this could very well be this is a secret, but because it's now encrypted, the parties in between who may or may not be able to intercept this information cannot actually view it. Once it is received by the authorized person on the other end, we can see it's decoded and this person can actually read the message now. So again, simple view of how that works, that there's a lot more to encryption than just that, but it gives you kind of an idea of, in general, the workflow that we tend to use when we go through these kind of scenarios. So how does encryption work? Well, we start off with a piece of data, very simple, and then we change it using an algorithm and a key. There are two components that we want to be able to utilize here. And again, this is to control access so that only people who have that correct key can unscramble that data and can view the content on the other end. So what is an algorithm? This is something that I'm a computer programmer by trade, so I hear the word algorithm constantly, but it gets kind of tossed around and it's kind of an ambiguous term in some cases. So let's go through just a quick description of what that is. An algorithm is just a logical step-by-step procedure that will give you a desired outcome if the steps are all followed correctly. For an example, if we take a number, add 12, multiply by 349, divide by 6, and then take the remainder, that is a general idea of an algorithm. To make it a little bit easier to understand, think about something like chocolate cake. A recipe for chocolate cake is, for all intents and purposes, an algorithm. It's a series of steps that, when followed correctly, will produce a delicious piece of cake, and that's what we want by the end of this. First thing you do is preheat the oven to a specific temperature, then you combine the ingredients in specific proportions. To bring it back to encryption a little bit, then we're going to add a secret ingredient that only you know, and then we're going to mix that batter, bake it, cool it, frost it. If all of these things are done correctly, then you end up with chocolate cake on the other end. Make sense to everyone? Good. All right, let's keep moving. So what is a key? This is another question that comes up fairly frequently when we do our webinars on encryption and cryptography. What is a key? And a key, in general terms, is a string of bits created explicitly for scrambling or unscrambling data. The longer the key, the harder the encryption is to crack. So when you see things like RSA 2048 or RSA 4096 as encryption standards, that 2048 and 4096, what they're referring to is the length of the cipher they're using to actually encrypt that data. Bigger equals better in most cases. And this is why when we see things like RSA encryption, we consider it to be, once we get above a certain level, basically unbreakable. It would be computationally impossible, or improbable, I guess I'd say, for a computer to figure out what that encryption sequence actually was. So one of the primary elements of computer systems that make things like e-commerce and finance work. Without these, they likely wouldn't. We also have to remember too that when we're sending data back and forth on the internet, or when we're storing data in the cloud, realistically, this is all just numbers. If we look at something on the back end, every piece of data that you look at, every picture you look at, every movie you watch online, all of it is just a series of ones and zeros. And we can encrypt that. It's all just math to us, which is really, really nice, including something like this picture of a dog with an adorable kitten. All of this on the back end is just a series of ones and zeros. So if we can go through and encrypt that so that it is in a more secure format, we can then send that as a secure image, and not everyone's going to be able to see it, which would be unfortunate in this case, but you get what I'm kind of going for here. The type of encryption we want to talk about here is going to be asymmetric encryption, also known as public key encryption. And in general, this means something pretty simplistic. Instead of there being a single encryption key that both encrypts and decrypts the data, we break this off into two elements. We have a public key and we have a private key. What one encrypts, the other decrypts, or what one locks, the other unlocks, I guess would be another way of saying that. For instance, your public key, or the keys you use for something like your email, those can be out there for anyone to view. It does not matter if somebody has a public key for this encryption cipher. In fact, that's why it's designed this way. Once that public key is out there, people can actually use that to decrypt any files that you send them. They can also use it for doing things like verifying your identity. Private keys, on the other hand, need to remain absolutely private, as is evident by the name. Private key is something that we want to make sure we keep completely secure out of the public view, because if that gets out there, all of our encryption is potentially compromised. We also use the same kind of concept for digital signing. This is verification that something like an email was actually sent from who you think it was being sent from. In general, again, you have two things. You have a private key and a public key. One signs, the other verifies. So if I'm sending you an email, I can sign that email with my private key, which you don't know. Once that email is delivered to your system, if you have my public key, you can verify that it works with my private key, and then you know that the email did actually come from me. This is, again, a primary way that we make sure we can verify identity on the internet, especially important in things like legal, or the legal industry, the finance industry, the education industry, anywhere where we need that kind of verification in place. Now, I say all this to basically bring up a fairly simple concept when we talk about something like cloud security. And that is how we balance something like usability and security. What is our convenience level? What is our security level? And when we look at these things, there's a fairly defined slope between the two. And we need to find kind of a balancing point in the middle. If something is very, very secure, odds are good it's probably going to be kind of difficult to use. There are exceptions to that, of course, something like facial recognition on your phone or biometric authorization on your phone. Very simplistic, but very secure. Not all of them are like that, but you get the idea here. On the other side of that, if something is very, very easy to use, then there is a pretty good chance it's not very secure. So we need to find that center point that works for us, our organization, and our risk appetite. How secure do we want to be versus how usable do we want an application to be? If we balance too far one way or the other, we cause problems, especially when it comes down to going too secure, creating a detriment for your user base and having them start to circumvent your security protocols, which is absolutely what we do not want. All right, so now that we know all of that, let's jump forward and do one more term here. That's going to be the concept of what's referred to as an access token. Now, an access token, and this relates directly to Microsoft, an access token is basically a small piece of data that tells some application you've already authenticated. You've already given it a username and password. You've already passed a multi-factor authentication check. You can use this application. Think about it kind of like a hall pass signed by the principal of a school. If a student has that hall pass and it's signed by the principal, that student is free to go pretty much wherever they need to go, obviously within reason. But if you don't have that signed hall pass, you are not authorized to be in that area, and bad things can happen. Now, this is really designed to make application usage easier while maintaining security. Things like tokens automatically become invalid in most cases after a certain period of time, or if you log out of whatever application you're using. So there is kind of a built-in safeguard there. The other nice part about tokens is that they're normally not stored directly on your computer, or at least not on the hard drive in a traditional storage sense. They'll either be stored in memory or in a temporary file. And then, of course, once they're made invalid, those tokens are gone. They're useless. They can't be utilized again. And we are on. Again, this is our balance between security and usability. If you've got this token, you've got a secure method of repeating your authentication without having to go through and put your username and password every time. That's going to be something that's pretty attractive to a user. So that's how a lot of applications, including things like Microsoft's Office 365, tend to function. All right. So now that we know all of that, let's talk about what happened with Microsoft. So Microsoft suffered a problem that likely originated a while ago. Back in April of 2021, they had a consumer signing system. That means a system inside of Microsoft that generates tokens for things like consumer accounts, Outlook.com accounts, personal email accounts, things like that. This system crashed. Now, in large software organizations like Microsoft, they will have procedures in place to view what went wrong with an application so their developers can fix it. In this case, they created a crash dump file, which is basically just a rundown diagnostic file of what went wrong with the application. This is sent off to a specialized group of developers. They're able to review this dump file and figure out what went wrong with the application, if this was a fluke, if it's something that needs to change in the code, whatever, really. Unfortunately, though, inside of this crash dump file, there was what's referred to as an MSA key. This is a master key, basically, for Microsoft's system, and it usually doesn't ever leave Microsoft's system. It's supposed to be kept secret. Microsoft stored this crash dump file with this MSA key in a local network that they have isolated from the rest of Microsoft's systems. And again, this is a security procedure. This is so they can view this file and not potentially expose any information. Now, here's the first mistake that was made in this process. Microsoft has automated software that will scan files that they're looking at and detect if there's a key or a password or something like that in the file. In this case, it did not detect that the MSA key was there, and that's unfortunate. We want to know when our data is potentially being exposed like this. That crash dump file, because it was viewed as not dangerous and not sensitive, was moved out into Microsoft's bigger environment. Now, this is accessible to a wider range of staff members. This means that other developers can pop in and look at it. It means it can be used for future research. There's a lot of good things that can be done with this information. But again, that's sitting there with that very secret MSA key in the file itself. Now, meanwhile, at the same time this is all happening, a Microsoft developer was actually in the process or was successfully phished at this point in time. This is where that Storm 0558 group comes in. A Microsoft developer was successfully phished. His workstation was infected with a piece of malware, and the attackers were able to basically steal his access tokens for Microsoft's network, use those to get themselves access, and start looking around inside the network. Once they were inside the network, they found that file with the MSA key, and now they can basically they can start creating their own tokens. We'll talk about how they do that here in just a second. But again, this is kind of a stark reminder about cloud security in general, especially when it comes down to the security of your user base. You want to make sure that your users are well trained in avoiding things like phishing emails. If they are not, you run the risk of running into a situation like this. And yes, even Microsoft, even one of the biggest technology companies on the planet, still suffers from a lot of the same threats that we as smaller businesses tend to suffer from. Now, I figured I'd throw this in here. This is what we see as kind of the standard attack chain for something like what happened to Microsoft. And you can see the general flow that occurred here. First off, a phishing email is sent off to someone's email address. Once the phishing email reaches it, the user clicks on it, and their access token is stolen and sent back to the attacker. Once it's stolen and sent back to the attacker, they can then basically replay that session, bypass multi-factor authentication because they have that token, they have that signed hall pass, and that gets them into whatever legitimate website they're looking for. Now, we bring up Microsoft this time around for the Cloud and Web App Security webinar as a cautionary tale. And really what this comes down to is making sure you're being careful about sensitive data laying around either inside your network or outside your network, making sure you understand where it is and what to do with it if you find it. This can include things like personal, financial, or health information, password files, which are oftentimes stolen by attackers, API keys, connection instructions, network maps. There's a lot more that can go into it. Basically, we want to keep this stuff on a need-to-know basis. It also underscores the importance of performing a data inventory and also an asset inventory. Make sure inside your network you understand what you are actually protecting. What are you the steward of at this point? This can identify sensitive data, it can identify sensitive applications, and it can really give you a very good view of what your risk level looks like with the data and applications you have inside your network. Highly recommend conducting this. There are automated tools that can do this for you that are very, very useful. Now, automated tools don't cover everything. We'll talk about that as we go through, but this is a really good time to think about, especially now that we're getting to the end of the year, budgeting for next year and thinking about doing one of these inventories can really open your eyes as to what you actually have. We also want to talk about those keys. That MSA key specifically was obviously not supposed to get out the door. And the fact that it did cause some problems. We'll talk about what exact problems those were here in just a second, but Microsoft is not the only organization who has suffered from losing something like a key. And in fact, there are a lot of organizations who run into problems like this. If you'd like to know more about this exact topic, highly recommend you check out Tom Pohl, one of our principal consultants and the lead of our pen test team, and the presentation he did for DEF CON in Las Vegas this year. He actually had a presentation called Private Keys in Public Places, ironic for this presentation. And he went through the exact process of how these keys are oftentimes hard-coded into applications, made available in software, and how exactly they can be used to break down the walls of your security system and, well, end up compromising you in the long run. Link for the presentation is on the screen. You can also find this on LMG's website, so highly recommend checking that out. You can even grab his slides if you'd like to. Specifically, look for the stuff on Dell Compellent software. That was a 0-day that our pen test team was able to publish right before DEF CON came out. Really fun presentation to watch. Okay, so let's get back to Microsoft here really quick. Let's wrap this one up. How did this happen? Well, Microsoft has given us their best guess as to how this actually happened. But unfortunately, due to log retention policies inside of Microsoft's network, they don't actually have data to tell us how exactly the Storm 0558 group got their hands on this key. This is kind of their best guess. So as they're saying, a Microsoft engineer's corporate account was compromised. The account that was compromised had access to that file. Because of this, the attackers now had access to the file and got out the door with that crash dump key. That's obviously not something that we want to see happening. So we'll reiterate one more time, and this time with some numbers. Employee cybersecurity and awareness training is huge. We're coming up on Cybersecurity Awareness Month, so this is a great time to talk about it. We also want to make sure that as we're doing our trainings, we are including things like social engineering attacks in our actual training. There are a lot of different types of social engineering attacks. There's standard phishing, there's voice phishing, there's SMS phishing. All of these things are dangerous. We'll talk a little bit more about these next month when we cover the MGM grand hack. Yeah, there's a lot to keep in mind as you're building out your training program. How frequently you're doing it, how in depth you want to go, and what exact elements you want to test, because you can't test them all at the same time. On the plus side, if you do train your employees, on average, according to IBM anyway, in their cost of a data breach report, you can reduce the cost of a data security incident or a security incident in general by about $247,000. And that's just through the virtue of training your employees to act as that line of defense. I will stop short in saying that employees are the weak link in a security system, but your employees and your forward-facing infrastructure are always going to be the most targeted elements that you have access to. They are oftentimes the public face, and so we want to make sure that they are given the tools to defend themselves and defend your data and your assets. So let's talk about Microsoft. This is our one of our last slides on them. Then we'll jump into some other interesting examples of web app security mishaps. What was the damage from Microsoft? What did this MSA key actually provide the attacker group with? Well, upwards of 25 organizations were compromised, and the start date of this compromise is kind of unclear. We don't actually know exactly when this happened, but contents of inboxes could be viewed, could be exfiltrated. I mean, there's a lot that attackers could do with this MSA key. Realistically, what they could do, based on a flaw in Microsoft's API system, was they could basically create their own tokens for enterprise applications using this consumer key. They could sign their own hall passes at this point. They didn't need to have Microsoft do that for them. Normally, this would not be possible. A consumer key couldn't be used to get access to enterprise information. In this case, though, it did, which is unfortunate, but it did highlight some things that are trending in the industry at this point, especially the theft of that token. Cyber criminals are stealing these things left and right. In fact, a lot of malware, a lot of information stealing Trojans, a lot of standard viruses that we see are really built to go after these kinds of pieces of information. We can see a few examples here on the screen. There was a company called Rollbar who suffered a massive data breach because their internal access tokens were stolen. We can see a story from VMware, 7 OAuth attacks in 10 months, the new generation of supply chain attacks. I mean, this is something that we will see moving forward. So protecting those keys and protecting our access into our systems becomes paramount at that point. So we'll wrap up with what Microsoft did. What did Microsoft do after they discovered this problem had happened? Well, they actually took quite a few steps that were pretty welcomed. And to Microsoft's credit, they responded about as well as anyone could have to this happening. This was not one giant incident that led to a hack. It is, as we oftentimes see in cybersecurity, kind of death by 1,000 cuts. There were several little mishaps along the way that led to a larger overall compromise. So to start with, Microsoft identified and fixed the issue they had that prevented them from detecting keys in those crashed up files. That should be first and foremost on their list, and it's kind of what they went for. They also updated how exactly those files handle information. If we can have those files just redact or remove that information ahead of time, we don't really have to worry about it that much. So that's another nice way to maintain that level of security. We also saw them put in enhanced credential scanners for their debugging environment to see if any other files were potentially exposing credentials or keys or anything else like that. They have updated APIs to prevent that cross-signing thing, and all the known users of this event have been notified already. So if you haven't heard from Microsoft that you were a victim here, odds are good you probably were not a victim. They have a pretty good handle on whose accounts were compromised. So this leads to a question that we get when we talk about a big company like Microsoft suffering a security incident. And of course, they're not the only one. Recently, we've seen Okta, we've seen LastPass, we've seen NVIDIA, we've seen Sony more recently. All of these companies are large and have very, very big and well-developed security programs, but they do suffer incidents. So how do you protect yourself when a cloud provider gets hacked? I mean, we can hammer on you about multi-factor authentication and good passwords and things like that, but what if the hack happens outside of your reach? Well, there's a few things that you can do here. One, and I think this is probably the most important, we talked about it with the data inventory, is to know what data you store and limit what you have available. If you don't need the data that you're holding, get rid of that data. It is the single cheapest way to lower your cybersecurity risk posture and make it so that you are in a better position to defend yourself. We also want to talk about using things like data loss prevention controls. This can help you realize, especially if something like your cloud email is compromised, it can help you realize if sensitive information is being either sent back and forth via email, or more importantly, sent outside of your organization via email or SharePoint or something else like that. Email encryption becomes a really important thing here too. For email encryption to function properly, in a lot of cases, you will have your own encryption key stored on your own computer. That means if somebody breaks into the cloud version of your application, even if they have an access token, they don't have that encryption key and they can't view the actual contents of your email. That's huge, especially when we talk about overall security. Last, we want to include things like conditional access policies and impossible travel alerts. Get a notification when something weird happens with one of your accounts, and make sure that you're checking using some enhanced monitoring and logging. Save those logs from O365. Make sure that you're maintaining a good log database. That can be really helpful for you. Okay, so we'll move on from Microsoft at this point, and let's talk about what happens when the data leakage or the loss of sensitive data isn't necessarily from a hacker specifically. In a lot of cases, when we see web applications being developed quickly and put out without proper testing, we see mistakes in the code behind those applications. And one of the best examples I could possibly bring up at this point is actually a flashback. And I've gone through the story a couple of times before. Honestly, it's one of my favorite cybersecurity mishap stories, but it is Missouri, and we're going to flash back to 2021 for this one. So the Missouri Department of Elementary and Secondary Education went ahead and published a web application that allowed anyone with public internet access to log in and look at the teachers that were operating inside their state. They were able to see things like their qualifications, their certifications, their whatever else about the teacher they wanted to know. Public information. It's something that we would like to see. Unfortunately, due to a slight, we'll call it slight mishap, they accidentally ended up exposing things like the social security numbers of over 600,000 educators inside the state. Now, what happened to Missouri to create this kind of a situation? Was it a hack? Was it what do we like to call them, a sophisticated and coordinated cyber attack or something like that? No, the answer is no. It was not. This was a flaw in their web app. The web app itself was set up to query a database from the state that had a lot of information about these teachers, including things like their social security number, their address, their date of birth, their phone number, and a lot more. These are things that you don't want on that public website. Unfortunately, the application that they ran pulled all this information back into the web page. Now, it only displayed certain things. It would only display things that they intended to have out there, but all of that information was available in the back-end coding of the website. So how do you access the back-end coding on a website if you're looking at it through a web browser? Well, the answer to that is actually pretty simple. For most web browsers, you can simply right-click and click on a button that says View Page Source. That'll bring up the code behind it, or you can just press F12. And this is what kind of became the, I don't want to call it a joke because it was a serious situation, but this was a running theme with this case. They kept calling it being hacked by F12. We'll talk about in a second why it was not a hack at all. It was simply a misconfiguration of an app, but this is not something that is unique to Missouri. I don't want to make it sound like they're the only ones who have been through this. Another organization, I'll throw this up as just one of many examples out there. An organization called Pen Test Partners was able to view the same kind of information in a shopping and e-commerce application called Gumtree. This came from back in, I believe it was 2022. But by going onto the Gumtree web app and pressing F12 to view the page, they were able to view things like the GPS locations and full names of the users that were using that website at the time. Not super sensitive data, but this is a data leak. This is what we don't want getting out there. I mean, we want to limit the amount of data that we're making available in our applications, make sure that we're not putting things out there that don't need to be. All right, so let's get back to Missouri here for a second, because this is where things took a hard left turn. This ended up all over the internet. People on Twitter were weighing in on this. Jen Easterly from CISA actually even had comments on this. The governor of Missouri kind of lost it at this point in time. Came out, gave this big press conference, and publicly claimed that Josh Radon, the reporter who had actually discovered the flaw in their website, was a hacker. He claimed he was only doing this to embarrass the state of Missouri and threatened to take the full weight of Missouri's legal system against him in order to stop him from hacking any more websites. And he was really serious about it too. Like, the press conferences were animated. This guy was mad. But was this actually a hack? The obvious result from this is no, it was not a hack at all. I mean, you can't sue someone because they pressed F12 on your web page. That's not how the internet works. That's not how security works. In fact, the FBI came through, published a 174-page report and came to about that exact conclusion, that this was information that was, for all intents and purposes, just made publicly available by accident. So they could not take legal action against a reporter who just happened to report that this website was misconfigured. The governor came out and finally said they were not going to file any legal action against the journalist, although still claimed it was a hacking incident, which was funny to watch him try to backpedal, but not fully admit that he had been wrong about what he said. Yeah, interesting things happen when cybersecurity goes wrong, and this is just another example of that happening. But insecurities in web apps, again, are not uncommon. We see them a lot. In fact, I have a case study here for you. This is a web application that LMG worked on, our penetration testing team. And we did what's called a web app security assessment on this. It's one of the services that we offer for actually primarily this purpose. We want to take a look at your web app, see if there's a problem with it, and see if you're putting yourself in a dangerous situation by releasing that product. So this was a business application for a client that we were working with, used by a financial institution, and it was used to process sensitive documents that were provided by customers. Nice application to have, especially if you're working in the banking industry. If you need to submit things like your driver's license or passport or any other kind of verification info, nice to be able to just do that through the cloud through an app. I mean, it's simple. This application was developed by an outsourced cybersecurity firm. So the bank didn't, or the financial institution didn't build this themselves. They farmed this work out to a software development company. The software development company charged them a ton of money to make this, claimed that it was fully secure, but before it went live, they decided to have us take a look at it. And we were actually able to reveal multiple flaws inside this application. I have a couple of the more egregious ones here, but let's take a look at one. So what you see here on the screen is us looking at the calls that are being made back and forth with this application. And you can see up here at the top, we have a token access token username and token access token password. We were actually able to, while we were logged in as a regular user account, change the passwords for any other user account that was on that system, including the administrator accounts. So if we just knew that an administrator account was there and we knew the name of it, we could go ahead and change the password, and now we have access to it. That is not something you want a standard level user being able to do in an application, period. There is no excuse for something like that out there. There were other problems that were very similar to this. In fact, they also had the press F12 to view sensitive information problem, but this was just a couple of examples. It also underscores the importance of testing your web application. So I mentioned before, this was a web app security assessment. Automated scans against applications like this can't find everything. So if you're doing a web app security assessment or an application assessment, what you're doing is basically hiring an ethical hacker to come in and find those weaknesses. They can take the results of a scan and extrapolate from there. And oftentimes they find a lot more than a scan just will. This is essential for understanding what your risk is going to look like. We want to identify issues ahead of time, make sure they're fixed, and make sure that just by virtue of having an application out there, you're not exposing data that you shouldn't be. Along with the coding errors, we also found vulnerable third-party components being used inside of this application. And this, again, is not an uncommon situation for people to find themselves in. In a lot of cases, these applications are built with a lot of open source libraries. And in some more recent cases than others, we've seen these types of open source software libraries cause massive issues for, well, people all around the world. In this case, we saw vulnerable instances of the movement.js library. We saw a PDF producer that was ripe for exploitation, and a lot more. This is just a couple of the ones that we found. To give you an example of how bad something like this can actually get, though, we only need to look back again to about December of 2021, and that's when we had the log4j vulnerability hit. This is the exact problem I was just talking about, but in action. Log4j came from an error logging service, open source piece of software that was widely used in a lot of applications. And there was a remote code execution vulnerability in that specific piece of open source software that then led to countless organizations being impacted. If you've watched any of our webinars, we have a great example of our penetration testing team using this exact vulnerability to break into a VMware vCenter server, hijack the administrative credentials, and take the server over. Didn't even take that long to do, but yeah, attackers could do a lot with this. Execute commands, steal your credentials, move to other computers inside your network, install malware, yada, yada, yada. You get what I'm saying here, right? This means it's really important that when you're using these applications, you need to understand what software is actually included in them. And this is where the concept of the software bill of materials really comes into play. We've talked about this before, but your software bill of materials, or your SBOM, is the ingredients list for your software. If you are curious about what software is or what other pieces of the application are running, something like an SBOM can tell you exactly what is in there. Also, if we see a vulnerable third-party library, you can check an SBOM and see if anything that you're running is going to be impacted by this, because it's not always apparent right away that there is a problem. We also want to talk about another thing here, and that's the vendor that you're using. So in the case of our web application, that was an outsourced web development vendor who created the app for them. And because they had some flaws in their development process, they were about to potentially put this organization at risk. Again, not uncommon. Your risk is your vendor's risk. This is a thing that we see repeated over and over and over again. AT&T recently, and this was back in March of this year, had to alert 9 million customers that their data had been potentially exposed after a marketing vendor that they were working with accidentally let that data slip publicly. This was not something that was a major hack. This was not something that was a major cyber attack. This was a simple case of mistakenly sending data where it shouldn't be. But because that vendor wasn't following proper protocols and made that mistake, AT&T had to tell a glut of people that their data was potentially compromised at that point. We also see things like API keys being leaked or stolen from weak source code. This happens, again, very frequently. There's an organization called Circle CI. They're used by a lot of software development firms. They actually went through recently and told all of their customers to rotate all of their API keys and their secret keys because an employee's laptop had been infected with malware. His session token had been stolen. Again, we just went through some of that. Account was hijacked, their production system was accessed, and just like that, their customer data and the encryption keys they were using to protect that data were out the door. Just like that. So common web app security issues, these are the ones that we see the most frequently when we're doing these web app security assessments. The first thing we see are what are referred to as injection attacks. And I want you to pay attention to that first one there, the SQL injection or SQL injection attack. This is like the MoveIt attack. I mean, frankly, this is what happened with MoveIt. The MoveIt servers that were responsible for tons of data loss just a couple of months ago were broken with this exact vulnerability. It's somewhat common. We also see things like broken or weak authentication. We see server misconfigurations. We see API security issues, vulnerable components, no logging or monitoring available. I mean, the list kind of goes on. So have those applications tested, have them checked out, make sure you're not falling victim to any of these. Now, you guys have heard me use the term API key here several times, and I wanted to go back and level set and just make sure that we're getting our terminology correct here, because we get this question a lot when we talk about some of these more complex types of cyber attacks. What exactly is an API key? These have come up in a lot of our presentations recently as a piece of data that needs to be heavily protected, that needs to be basically treated like it's the keys to your kingdom, because in a lot of cases it might be. An API or API key is just a digital identifier, kind of like a username and password, big long string of numbers. But this is the way that applications talk to each other over the internet. It's not like a username and password like somebody's typing it in. It's the credentials that something like your Outlook application uses to connect up to Microsoft. You have that API key, it allows them to communicate on the back end, and that's how your email is passed back and forth. If you lose that API key, attackers can do quite a bit with it. Basically, they can do anything that application could do. This could mean things like unauthorized access to your data. It could mean a full-on data breach if we're in a bad situation. There could be financial loss because of this, service outages because of broken applications. The list, again, kind of goes on there. The other thing, too, is that API keys can survive things like password resets, and that is a big problem, especially when we're talking about some of the initial steps that we take when a cloud account is broken. One of the very first things we tell people, change your password. Change your password, reset your MFA sessions, go through and do those basic steps. If they're accessing it with an API key, they don't necessarily need any of that information. They don't need your username and password. They don't need your MFA key. They're just going to use that back-end channel to go ahead and pipe data back out. Now, I mentioned we would talk about MoveIt, so let's talk about them here for just a quick second. This has been kind of the cloud app hack of the decade up to this point, and it's pretty bad, guys. Right now, we are seeing upwards of 2,000 organizations being hacked. In fact, the last known was, this is just from a couple days ago, 2,040 organizations, over 60 million people's information potentially compromised at this point in time. And remember who some of the names were that were hit with the Move It hack. We had things like, or we had organizations like Shell. We had organizations like PricewaterhouseCoopers. We had large banks, large legal institutions, large healthcare organizations. All of them compromised because of the hack of a single application. And it's kind of starting to get a little bit worse. We saw with PricewaterhouseCoopers as the intro into this one. The cyber criminals behind this attack are now starting to leak data on the regular internet, things that they stole from these Move It servers. This is customers. This is customers of customers. This is further down the chain. We're starting to see a pretty cascading style of effect on a lot of organizations who have done business with people who have been hacked. Now, the reason I bring this up is kind of twofold. One, this is on the public internet, not on the dark web. We're used to seeing this kind of data leaked on the dark web. That's nothing new, but seeing it on the public internet is. And this is problematic for a couple of reasons. One, it means that anyone can access this data. Anyone with just a regular internet connection and a standard web browser can get to this data and download it. They're just simple URLs and zip files. The other bad part about this, though, is that Google and other search engines like it can actually index this data now. So you can search for a data breach using a standard search engine, and that is going to expose this information to a lot more people than if it was simply just available on a darknet forum, a darknet marketplace, or something like that. The other reason we bring this up is really to hammer home the fact that attackers are targeting cloud systems. This is another one of those trends that we've seen recently, where especially ransomware groups are realizing that a lot of people are utilizing cloud systems kind of as a proxy for a backup. They think that by having their data in the cloud, it makes it almost immune or invulnerable to an attack like a ransomware attack. And the sad reality behind that is it does not. And we have examples of that to go through. Cloud Nordic, as an example, which you can see on the slide in front of you, was a large-scale data hosting organization. And yes, they were coming out of Norway, but they're not the only ones who have suffered by this. Their infrastructure was hit with a massive ransomware attack. So they're acting as cloud storage, and their infrastructure goes down. What does this mean? Well, it means anyone who is storing their data in that storage has now lost their data. And Cloud Nordic has come out publicly and said they are not going to be able to recover a majority of the data from this from their servers. It's just gone. There is no getting it back. There's no backups. They're kind of dead in the water at this point. We also see other large-scale groups like Black Cat developing new encryptors that go specifically after things like Azure storage. And they have a recent one that was just discovered, and we saw this article pop up in Bleeping Computer a few days ago. There's a new encryptor called the Sphinx encryptor. Get it? Black Hat, Sphinx, they're very clever. But this specifically goes after Azure storage and encrypts the data that is held in your cloud environment, making things a lot more difficult for you to recover from, especially if you're relying on something like the rollback feature in SharePoint or versioning or something like that to keep your data safe. So we want to make something very, very clear here. We talk about backups a lot when we're talking about local systems, but local systems aren't the only ones that are impacted by these attacks. And so we want to make sure you are backing up everything. Make sure that your backups are immutable. Make sure you have decent retention times on your backups. Make sure you're going after your VM environments. Make sure you're planning for restoration times if you are hit with a cyber attack. And most importantly, test your backups. If you don't test your backups, you don't have backups. It's a simple concept, but we've seen it cause problems in more than one incident. Don't want to see any of you fall into that trap. And again, make sure you include your cloud in that backup routine. Now, we keep talking about cloud, so I'd be remiss not to talk about how attackers actually make their way into those cloud services. Microsoft 365 systems are and likely will continue to be the most targeted and exploited cloud services on the planet. It makes sense why. They hold the greatest market share, so it goes along the lines with kind of the same reason why Windows computers get more viruses than Macs or Linux computers. Does it mean that viruses don't exist for Mac or Linux computers? No, it does not mean that. There are viruses for those. However, since Windows controls that much of the market share, it makes sense why cyber criminals would want to optimize their operations, go for the big fish, and get as much as they possibly can. Cloud services are no different. Microsoft's Office 365 email and SharePoint are by and large the most frequently used cloud email and cloud file storage platforms. So attackers are going after them very specifically. Now, I want to give you guys an example of how an attacker can go from inside your network, if they get access to a computer or something like that inside your infrastructure, how they can make that jump to the cloud. And as we have loved to do so frequently in recent memory, we're going to start with a printer. We've really, on our offensive testing team, started to love printers because they give us keys to so many different elements of a network. And in this case, we're going to show you exactly how we did this. So this was a printer that we found on a network. We were pen testing. And these were the settings in their email scan system. So the very first thing we can see here is there is an SMTP server that is set up in the mail configuration. You can see by the URL on that, protection.outlook.com. This is going up to a Microsoft server. Now, in this case, SMTP authentication was turned off, as you can see down on the bottom, but there was a saved email address and user password. Username and password that were included in the configuration. Now, this is all redacted. We can't see any of this inside the menus, but we know it's there. So what are we going to do at this point? Well, the very first thing we're going to do is we're going to change that mail server that it's looking at sending out to. We're going to make that our server instead. I blurred it out because you guys don't get to know what our server IP is, but this means that if this thing tries to send an email, it's no longer going to send it to Microsoft. It's going to send it to us instead. The other thing we want to do is get those credentials. So now we're going to turn on that SMTP authentication. We're going to make it try to log into our server with a username and password, because if we can get it to do that, we can probably get that username and password. That might be helpful for us. So let's see how we do this. Now we need to trigger an email. We need to make the system, trigger off some kind of notification or alert or something like that. And to do so, we need to basically prompt the machine to make that action. Now, there's a couple ways we could do this. We could just sit back and wait for somebody to try to scan something to email, but we don't know how long that's going to take. And if the scan doesn't go through, then potentially we're going to be discovered, and we don't want that. We want to make this a quicker process. So what we can do in this case is turn on notifications. How many of you have ever received a notification from your printer that it is either low on paper, low on toner, there's a paper jam, or something else along those lines? A lot of times those get done through email. So we wanted to go ahead and turn on every notification that we possibly could, and lucky for us, the printer was almost out of paper at this point in time. So by having that low paper condition, by turning on the notifications, and by having our server in the configuration for this printer, we went ahead and triggered an email. It went ahead and tried to let us know that we were low on paper, that we were getting into a bad position. We needed to fill back up. Along with that, we got those SMTP credentials. This means that we now have the username and password that this printer is trying to use to log into whatever email account it was. This is also a domain administrator level email account, which is not uncommon when we look at things going into Microsoft 365. Oftentimes during the initial setup of something like a printer, if they can't get the scanning to work correctly, they'll go ahead and put an elevated username and password in there. Once that works, a lot of times the copy tech will back off, not touch it again, because if it's working now, they don't want to break it. They're done. They're out the door. It does not get changed a lot. In fact, in our experience, 40% of the time, printer credentials are domain administrators, 100% of the time. I know that makes no sense, but it totally does, I promise you. All right, so now let's take this to the next level. We've got a username and password. We know this was originally going up to a Microsoft email account. So let's try this on Microsoft's system. Let's see if we can log in to an email account with the username and password that we've just stolen. And should not surprise you, we were totally able to log directly into that account. Now, here's where things got bad for the client we were working with. This really illustrated a massive security risk for them. Typically, the inbox of a copier that's being used for scan to email will contain things like auto replies. It's not normally, you won't usually see anything in the inbox, like nobody's sending an email or anything like that. But if we send an email off, then we'll get an auto reply saying so-and-so is not available, or something like that. And this can mean that data is removed or returned back to the inbox, and we can see what was actually sent. We can also see all the docs the printer has ever actually scanned, because down at the bottom we have a sent items folder, and in this case the sent items folder was not configured to be cleared out. Any email that that printer had sent was also included in that sent items folder. All the emails from that printer, oh, and by the way, every other printer on the network, because they were all using the same email and password as their scan to email base. So we had to redact a lot of this because there was a lot of sensitive information. But yeah, this meant by taking over that one single printer, we had effectively taken over the credentials for everyone in the network, and now we had access to everything they had scanned going back, I think, like 8 months at this point. So that's pretty bad to find. And this is what attackers will look for. I mean, if they can get their hands on something like that, a lot of sensitive data in there. It was scanned health forms, scanned financial records, a lot of things that you wouldn't want getting out the door. And again, if an attacker can get their hands on that, they can hold you hostage for that information. So the way that we advise people on this one is to conduct cloud configuration reviews. We want to make sure a couple of things. One, that you're properly utilizing those scanning systems and you are properly utilizing the systems they're connecting to. So we want to make sure you're inventorying the data that you have in the cloud, the applications that are using it, and we want to prioritize based on criticality. If we're using M365 for pretty much everything, that's going to be our primary focus. We also want to conduct routine configuration reviews. This can help prevent things like business email compromise attacks and data breaches. We also want to make sure we're integrating with the security products that we already have available. If you're using Microsoft's M365 system, highly recommend checking out something like their Sentinel integration. They have some new artificial intelligence add-ons they're putting in there that make it very easy to use, and it can tell you a lot about what's going on inside of your tenant kind of at a glance. Okay, so moving away from Microsoft, let's talk about one of the other majorly popular cloud services out there. Let's talk about Amazon S3. So we've seen multiple examples of how S3 has caused data security incidents for companies all around the world, and oftentimes that comes down to something like a simple misconfiguration when something like an S3 bucket is created. Now, I want to show you how we can exploit something like that. So if I can get my hands on the IP address of your S3 bucket, I may be able to actually exploit it and pull the contents back down out of it. It's not as simple as just logging into the S3 bucket. There's a few steps that I have to make, but let me show you how something like that would work. So I'm going to start with an IP address, and I'm going to use an application called Dig. That's going to give me the fully qualified host name of that S3 bucket. So now knowing this, I have a full URL I can use to communicate. Now let's see if this is properly secured. I'm going to use an application called curl. This is not anything special. This is something that comes standard on most Mac and Linux operating systems. I'm just going to send a command up to this, and what I'm going to ask it for are the security credentials that are authorized to utilize that S3 bucket. You can see that -h command here at the end. I'll explain what that means here in just a second, but I'm going to query that server and see if I can get that identity and access management role name returned back to me by the system. And as it turns out, in this case, I can't. That means that the proxy settings on this bucket are not configured correctly. This is something that we see very, very frequently when organizations are moving from on-premise to the cloud for their data storage. They'll make a configuration change to something like S3, makes it easier for them to send their data up there, but that change oftentimes does not get reverted, and it means that that system is now potentially vulnerable through something as simple as getting the IP address. So now let's abuse this one a little bit. Now we know there's a misconfiguration that we can go after. So let's see exactly what we can get back out of this. The very first thing I wanted to point out again is that -h modifier I'm putting onto this command. What I'm basically telling Amazon right now is that the call that I'm sending to it, the information that I'm requesting, is coming from inside of their network already. This is the the AWS metadata URL that we're going after here. So we'll go ahead and send up basically that same command we sent before, but with that role name and with that modifier saying we're inside the network, and it sends back a bunch of information to us, including the access keys and the session token, those things we were just talking about. So what can I do with this stuff? Well, I can do a lot with this. If I have the keys and I have the session token, now I can basically take over that S3 bucket. So that's exactly what I'm going to do. I'm going to set up a new profile, and we are going to create that profile with the keys that I just stole from the S3 bucket. The other thing I'm going to do is add that session token into my user. This means that now I can log in as that metadata service, or as that identity and access management service role. This means I pretty much have access to everything. So now let's go through and list all the available buckets, and here's that happening. This lists off all the contents. It tells me the names of the buckets, when they were last modified, and it gives me some indication as to where I might want to go. In this case, let's go ahead and take a look at the sensitive data bucket keep out, well, data bucket. By just running a simple sync, I can now download everything that is in that bucket because, again, I have the credentials and the session token telling Amazon's system that I've already authenticated and I am good to go. I don't need any more verification. I have total access to this, and I can go ahead and pull all that information down. This is basically, if you remember back to the Capital One hack, this is how Capital One was hacked when Paige Thompson broke into their S3 system along with multiple other organizations and stole information on a ton of their individual users. Things like credit card applications were stolen. It was bad, and it turned into a big fight between Capital One and Amazon. If you've never heard us talk about this one before, go and check out some of our previous webinars. We've covered this one a few times. It was cybersecurity soap opera at its finest. But this is basically the exact misconfiguration that led to that problem. So to end out, we will talk about our last element on the list, and that's going to be leveraging identity and access management. If there's one thing I could tell you to do in your cloud systems outside of username, password, and multi-factor authentication, which everyone tells you, it would be to utilize something like a strong identity and access management framework. We want to make sure that we're restricting access to accounts. We want to make sure we know if an account is misused. We also want to make sure we can automatically respond if an account pops up on a bad list. And this can also act as a central identity provider for other services. If you're using identity and access management through something like Azure, that can be a great place to leverage single sign-on and have a lot of your other applications go through there as well. It is a very secure option, very easy for your users to actually function with. And it makes things easier for your IT staff. All those things are good. Of course, it can be misused like other services can, but it is still a very, very secure option. All right, so we'll end out today with our top security controls of 2023. We've included this in a few of our webinars up to this point, and we have it as a handout available to you in the webinar today, along with a cloud security handout. The ones that we talked about today specifically were as follows. We talked about employee cybersecurity training and awareness. We talked about identity and access management. We talked about cloud configuration management. We talked about penetration testing. And we talked about data and asset inventories. All of these things are going to be useful to you in making sure your security posture is up to date and ready to take on the challenges that are coming up over the next year or more. All right, so I will turn it back over for any questions. Again, my name is Matt Duran of LMG Security. Thank you so much for watching. If you have any questions after the webinar, please feel free to email me at info@lmgsecurity.com. I always love to talk to you guys. And yeah, I will turn it back over to Sarah if we had any questions from the group.
Thank you, Matt. We had a few questions that came from our audience during the presentation. One of them was, do you think that MSI private key theft is more serious than the Microsoft hacked?
Oh yeah, the MSI private key theft. Yeah, that's a bad one. The problem with the MSI key theft is that, as far as my understanding of the situation goes, that allowed people to unlock and modify their BIOS firmware, which could lead to all kinds of cyber attacks. I would say it's going to be from an overall severity standpoint, yes, that would be more severe. From a practical standpoint, it would be more difficult for an attacker to actually leverage that type of an attack. So I think we'd see it a lot less frequently, but yeah, they're both awful. Like neither one of those is a good thing.
Another question is, what are the best simple steps I can take to protect my cloud accounts?
Yeah, your cloud accounts. So if you're talking about your personal cloud accounts, realistically, we go back to the basics on those. So make sure that you have a long, unique password. Make sure that you're using a password manager to maintain it. Make sure you have strong phishing-resistant multi-factor authentication. And then in a lot of cases, especially with something like Gmail or like Outlook, you can actually see where recent logins came in from. So we recommend periodically checking that. Make sure that the logins to your account are coming in from an authorized area. If we're talking about enterprise accounts, email encryption, data encryption, making sure that if somebody does get access to the information you have, it's not useful to them. That's kind of the name of the game at this point.
Thank you. And one more question is, what is the best way to make sure my web apps are secure?
Best way to make sure your web apps are secure is to test them and test them thoroughly. If you are outsourcing your software development to someone, if you are buying a new application to use, if you're integrating a new application, get another set of eyes on it. Make sure that you understand the risks of using that piece of software. And realistically, web app security assessments, they don't take that long and they're not that expensive. They can save you a ton of time, hassle, and money down the road. So we always recommend people thoroughly vet their applications. If you're going through another organization who already has their application built, see if you can get a request for one of their security assessments in and actually take a look at it. Oftentimes they'll provide it to you because, well, if they pass it well, then that's kind of a badge of honor for them. So yeah, again, just test.
Well, thank you for those answers. But most of all, thank you, Matt. Once again, this is Sarah with LMG Security. We'd like to thank everyone who attended. Thank you all, and I hope you have a wonderful day.
Thank you so much, everyone. Again, my name is Matt Duran, Director of Training and Research for LMG Security. If you have any questions, please feel free to reach out at any time. We would love to hear from you. You can reach me at info@lmgsecurity.com, find me on LinkedIn, or follow us on Twitter. Thank you so much, and we'll see you next time.